as everybody knows, it defines the image or the video resolution of your output file. Basically, everybody will most likely to render out, if you want to render a 3D scene, you will most likely to render into an image. So this is basically controls the resolution of that image or video if you are rendering out into a video. In case if you don't know, Blender also edit video, that's why it also render in a video format. Down here is the aspect ratio. It will change the aspect ratio of your image besides the resolution. Well, the frame range, as we all know, it defines the frame range in the timeline. We can also change it from here. The frame rate is really important, especially when you're rendering a video output and also when you're creating some animation. As the panel name mentions, these are dimensions, so it are basically more or less some dimensions and some basic attributes of the output file. Down here will be some other panels, most of them which I will not be going in detail or won't be even discussing about in this video, but I will just touch the very basic or important ones. This is output panel. In this panel you can really control what output you want, where you want to output, and some other, like how much compression do you want for your output file, and some other values to choose from, like what is the color output you want, black and white, red, green, blue, or red, green, blue with alpha. So it's like BW, RGB or RGBA, and the float color depth 16 bits or 8 bits. So these are very basic attributes when you are thinking about what output you want. Now down here is the sampling panel. Now this is very important when you are rendering a high quality image, so you have to really adjust them up the sampling. This is really important when you're rendering your final image or you're testing rendering material stuff. So turn this samples up and down according to your needs, and this will change the look and quality of the render. Normally I wouldn't suggest changing anything, but just turn this square sample on, and without changing anything, just crank the render sampling up. Now the render and preview samplings are two different types of sampling. One attribute is taken into account when you are rendering the final result. The other, which is the preview render, it is sampling for the preview render of your scene, which is done right in the viewport. So this is used when you are previewing your animation in the 3D viewport, and this is used when you are rendering the final image. Down here are some other options for geometry, like path. You might in some cases want to adjust them as well, but these are not needed much. Fill, motion blur, and performance, post-process, bake, and other stuff. But for now, we just need to crank the sampling up a bit. And going into the performance, just change the tile 125 in the X and 125 in the Y. And just hit render. And by the way, I just forgot, this percentage changes the percentage. It's basically a multiplier of this main resolution. It will change the overall percentage of these resolution altogether. So try to render this up and see what it gives us. Now this is how our render looks. Well, it's pretty noisy and it has fireflies all over it, and mostly they are on this class object portion, but they are some of them are here and there as well. This doesn't look good. And also I just really forgot to talk about a really cool and new feature in Blender, which is called the denoising or the denoiser. It is right under this render layers tab. All the way down here you will see denoising. It will have a checkbox right next to this arrow. All you have to do is check this, and when you open this up, it will give you some options and attributes to change, adjust, or select. Just leave them as they are. It's a good piece of advice. Now going back into the render settings tab, right where the sampling or samples are, and crank them up a bit. In this case I will say 100 will do fine. Well, most of you might think that 100 might be too much, but I don't think so. 100 will be fine. I think it's a standard sampling rate for a good quality render. We could also choose 80 or 70. I think maybe they would have worked, but I think let's just, because since we have glass object and there are so many fireflies, even with the 40 sampling, I think 100 might still relieve a lot of noise and fireflies. So let's just pause the video and render this real quick. Well, it still doesn't do any good. So we're gonna crank the sample up to something like 200 and we will re-render this. Now the render is complete on 200 samples and it's still noisy, but it's a lot cleaner than previous two renders. There is a reason behind that why the sample is too high and it's still too noisy and took so much time, but we're not going to discuss that thing in this tutorial, and there is a way to get better result in lesser time, but this is just to show you a quick way to show how rendering process is done in Blender. This video tutorial is to show you how each and every individual aspect of 3D computer graphics, or how each stage of 3D computer graphics is done in Blender. It's just to show you how you can do different things in Blender. Let's just say this first chapter is for beginners and newbies. When this first chapter is complete and we are going to move into the second chapter, we will become more advanced and there will be side chapter or side course that will be dedicated to really advanced user, and they will be fun to learn. Now, since the rendering is complete, let's just move on to simulation in Blender. Simulation is motion of one or several objects or particles created by the interaction of real-world based physical forces with the help of computers' calculation power, hence creating animation that is otherwise tough to create by hands. Because now, one thing you should note that I didn't say simulation is motion. What I said is simulation is motion created by interaction of real-world based physical forces. Okay. Simulation is important because otherwise we won't be able to create this type of animation, because it will be really difficult to animate several different objects, because otherwise it will be really tough to animate several different pieces of an object at the same time. Otherwise it will be really difficult to animate motion of several different pieces of an object based on real world physics, or otherwise like animating debris, smoke, or particles, or even to rig something that acts like fluid, or that acts like a dynamic object like cloth or other things. Well, there are three different types of simulation. One is done on 3D mesh. One is a simulation of 3D meshes or 3D objects. The other is simulation of particles, and the third one is hair simulation or fur simulation. Well, first we're going to talk about some particle simulation. So let's just create a plane for this purpose. And one thing you need to know that if you're going to create particles, you are doing any type of simulation, whether it's particle or it's rigid body simulation or soft body or clothes, you have to create a mesh, because Even the particles are created with the help of 3D mesh. 3D mesh acts as an emitter, and particles need some sort of an emitter to be emitted out of. And basically these particles are emitted out of 3D polygonal objects. You can only polygonal objects to create these particles off of. Otherwise, other objects like NURB surfaces or metaballs or subdivision surfaces won't help you create or won't act as an emitter for these particles. And hence these 3D components or 3D mesh acts as an area for the particle to be created or to be emitted out of. So let's just go ahead and create a plane. Select this and bring it up in Z-axis. Now, first thing I want you to know that you can do this with other objects. Like for instance, if you select light, the particle tab will disappear. Now going back to this mesh, select it and going into the property editor, and under the particle tab, click on this add new button. So right away you will see it creates a system and it gives you some properties. So let's go ahead and play this. You can see it is really basic simulation. Particles are being created and they are falling down because of the gravity, and then they disappear after sometimes in the middle of air or in the middle of space. Now let's just pause this and let's really quickly go through some properties. These properties will change the physical behavior of these particles, and we will go through some of them. Let's just go to the first frame in the time slider, and we will go through some of these, not all of these, one by one. We will go through a few of really important ones to just show you how simulation is done in Blender. Well, let's just start with the top. The very first panel, called the emission panel, we see the start and the end. Now these two decide at which frame the emitter starts emitting the particle and at which frame it stops emitting the particles. Now let's just type 5, or let's just say type 10 in it. And hit play. As you can see, it starts emitting the particle at the 10th frame. Now let's just type 50 in the end frame. And it almost ends at the 50th frame. Well, it looks like that it's still emitting after the 50th frame and it ends almost at the 60th frame. Well, this is happening because of another attribute that is cranked up in this system. If you go ahead and type 10 in the end frame so that the end and the start frame are the same, you will see that it just emits and stop emitting at that frame, as you can see here. But when it is cranked up a bit, it looks like that it's still emitting the particles even after it hit that frame. But this is not the case. Now what is happening is it is actually applying a initial velocity or initial force on these particles when they get emitted or when they are created in the direction of the normal of this mesh. Well, if you go into the velocity, you will see the value of the normal is 1, which is applying a initial velocity to this particle when they get created. So what happens is these particles go up after they are created before going down. So this looks like, or gives it an illusion that these particles are still being emitted after the end frame. So let's just type 0 in this normal parameter, which is basically an initial velocity for these particles in the direction of the normal of the mesh or the polygon they are being emitted from. And hit play. Now as you can see, the moment they get created, they start falling down. It looks like it is being created at the 11th frame, but it is actually created at the 10th frame, because the 11th is a very next frame, so you start to see these particles at 11th frame, because the frame 10th is complete or calculated at the 11th frame, so the result is shown in the 11th frame. So let's just type all those and then start value back and type 0 in the initial velocity of these particles and then hit play. Okay. As you can see, the moment it hits the 20th frame, the emitter stops emitting these particles. At 20th frame, the particles are being created, and at 21st frame, they stop being created. So if we type 50, you will see that the emission stops right at the 50th frame. So let's just go to some other attributes right here. Now this parameter here is called the lifetime, or it can also be called the time span of these particles. What it does, it controls the duration of time of these particles, or the duration of life of these particles, which means that how many frames that these particles will live after they are created. Now write down the lifetime. You will see random. What it does is it randomizes lifetime or time span of each particle. So let's just crank it up a bit and let's see the result of it by playing it. As you can see, there is randomization in the lifetime of these particles. A lot of these particles get destroyed before or get killed before the other particles. So let's just dial the randomization back to 0, and we're gonna talk about some other properties. These panels control different behavior of these particle system, like velocity, cache. Well, cache basically just bakes the entire simulation into a file, and velocity will give it a initial velocity in the direction of the normal of the polygon that these emitter are emitted from. Now we have physics, we have rotation. Well, normally I don't go through other few of these types of physics. I just stick with the Newtonian, which is the default one. These physics property will control some of the very basic physical behavior like mass and other. We can change it to other type of physics, but I most likely stick with the Newtonian. We can also choose no physical property at all. Now down here is the field weight. Here is the rendering. This will control the rendering property of these particles. And down here is the display. It will help you what sort of display you want for these particles, so you can easily see. Well, we can also choose none for some reason when we have to create a smoke and we don't want to see the particles. Instead we want to see some smoke and stuff. Well, under display you can change or choose what percentage of particles you like to see in your viewport, and you can also change the size of these particles. Now this panel is called children panel. What it means is when you want to generate more particles but you still want the simulation to run smoothly, you use this panel to create some extra particles that are created by each already existing particle, and children particle follow them in their motion. Instead of simulating all those particles, what it does, it creates those child particles which then follow their parent particle in their motion, and hence the simulation still runs smoothly. Now let's just choose simple and play back and see what it does. As you can see, some extra particles are created, and as you can see, this looks really dense because of the children particles. Now you can adjust some other values, the uniformity of these particles, the size of these particles, let me play back it once more, and here let me change the size of these particles, randomize the size, we can adjust uniformity, then randomize it, and we can also change the radius, the roundness, and we can change a lot of these properties to make it look the way we want to look, and you can see it looks really cool. This big sphere of particles look really cool. Let's just dial down the radius and make it look the way it looked before, just 0.2, and it looks fine. Now we can also change the look of these particles down here, and we can do this by changing this kink to curl or radial. And down here in the field weight is gravity. If we dial it down, you can see the effect of gravity on this becomes lesser, and they come down really slow. And if you dial that all the way back, there will not be any effect of gravity on these particles. They will get generated and they will get disappear, just like that. Now if you add a bit, it will come down slowly and slowly. The more you add, the more it will affect the particles. And there are some other forces and other physical behavior here as well, which you can change to change the effect of other forces in your 3D scene, if you have any. Now let me just close all this panel just to make things more cleaner and have less mess. And let me bring a plane with which these particles can collide. So going into this layer, and let's just duplicate this plane and bring it to that current layer we are working on. So select this and Shift D to duplicate and bring it to the first layer. Let's just go to that layer, and let me just go into the property editor, and under the physics tab add the collision. Now just by doing this, we can make these particles bounce off of this plane. And if you hit play, as you can see, they are bouncing back. And if we move this emitter, it creates a really cool effect. This is how we can make this particle interact with the other objects or through other 3D mesh. Now we are done with the particle simulation. Let's just move on to the mesh simulation, and let me just explain you how mesh simulation is done in Blender, and let me show you a little bit about 3D mesh simulation. Let me just explain you 3D mesh simulation in Blender. So delete this plane, and I'm gonna create a box for this purpose. Let me just show you a little demonstration. So move it up in Z-axis. Let me just create a quick simulation to explain you this subject in Blender. So now let's move this box up in Z-axis and scale it down in Z-axis, and then scale it up in Y-axis a bit and tilt it down. And now click on this rigid body button, and this will create a rigid body system on this, and select the type as a passive. Select the type back to active rigid body and play it. And you can see this just falls right through the ground plane. Select the ground plane. First, let me just delete the collision system from this plane, and real quick add a rigid body system and choose a passive rigid body. In order for the system to calculate the collision between these two rigid body, we have to choose rigid body for both of these. And let me just crank up the mass of this object a bit up. And as you can see, it's just acting pretty decent. Let me just move it up in Z-axis a bit more, and it just breaks through it. Let me just crank down the mass back again and let me play it, and it still breaks through it. Let me just check turning up the friction. No, it just still passes through. Let me now add some bounce in this. It still passes through. Let me add some bounce in the object, but it still passes through. Add full bounce for both of these, and as you can see, it bounces off of the surface, but the bounce is too high. We need to do something else. Let's just dial it back, and it bounces good. It doesn't bounce too much. Let's just dial down the bounce from both of these and test it, and it passes through. And I think let's just dial down the friction back, because I think this is the reason why this is passing through, but it still passes through this ground plane. Dialing back the bounce up again, and cranking and playing it, it plays pretty good. So I'm gonna crank up the mass of this object to 5 and see if it works. Yes, it does. Works great, but I still don't like the bounce. It's too high for this. It's like bouncing like too much. So what I want to do is dial the bounce back and choose from the type of collision, shape of collision, to the mesh for both of these. And it acts pretty fine. And I'm dialing the friction back up for both of these, trying it again, and it pretty much acts fine. So this is a basic 3D mesh simulation. So now I'm gonna create a scene, or I'm gonna make this animation a bit more complex and add some other rigid body in the system. So I'm gonna close the system, or delete the system from this box, and I am going to zero out all the rotation, and I'm gonna duplicate a bunch of these boxes, you can say, wherever it is. Now I'm gonna scale it down in z-axis and place it right here, and duplicate it also and place it a bit back, and then let's move it a bit up and move it closer. And now I'm going to scale it up in this one in y-axis and move it a bit back, move it a bit down and scale it more in y-axis. Now I'm going to duplicate this one and place it all the way here, and I am going to rotate it in x-axis a bit like this, and I'm going to add some rigid body system into all of these, or make all of these 2D mesh into rigid bodies. And let's just use this and type 5 in the mass of this one and change all of these to meshes, so the simulation is more accurate and the collision is more accurate this way. And now I'm gonna hit play. Hit play again. Well, for some reason this is not colliding with each other, so let's see what we can do. Let's just try and change the shape back to convex hull, the collision type for all of these objects, and let's see how they do. Let me undo it a couple of times and change them back to convex hull. Rewind it and hit play. This is working. Well, changing the type back to convex help because the mesh will make it hard for the computer to calculate, so this is why. Changing it back to convex hull is making it easy for the computer to calculate the collision. So hit once more and you can see the simulation is looking awesome. So to finish off this tutorial, let me introduce another type of mesh simulation, or another type of simulation in mesh. And that will be for the purpose of this tutorial. That will be the cloth simulation. So let me just create a plane real quick, bring it up in z-axis and forward in y, and hit tab to go in edit mode and subdivide it a couple of times. Now add cloth system and let's just hit play to see the result. Well, it passes through every other objects or even the ground plane. For this purpose we have to select the ground plane and add this collision from here as well and hit play. And as you can see, it is interacting with the ground plane and it is deforming well. So what I want to do is I want to add a subdivision to this, make this surface smoother and add subdivision on this surface because this is appearing to be really sharp or really jagged or something, really edgy. Now this makes it look better. And adding one more subdivision level for the viewport, and now I'm gonna hit play back again. I think the subdivision level is really low, so what I want to do is delete this subdivision modifier from the modifier panel and delete the cloth system and add more subdivision level on this cloth piece or piece of cloth. and up this level a couple of times. And now what I'm going to do is I'm going to add a cloth system first, and then I'm going to play it and see the result. And let's just go into the modifier tab and add a subdivision surface modifier. And this is looking good. Now I want to add some material or some color on this, because it is really hard to see this piece of cloth. It is really hard to see this piece of cloth when its color is exact same of those of the other object. So let me go into the material tab and add a material. And choose. And let's just change the color. Basically we need to go change the color. Well, it is not affecting the viewport color. What we have to do is we have to go down to the settings and change the viewport color from there. It's already called the viewport color. We can change the color of the object, or the viewport color of an object having this material. So we will change it to something like blue, and also add this specularity. Now we will gonna simulate this back again, and let's just rotate it a bit to see how the simulation is affecting this. Wow, that is really unexpected. How to say it? It was really this was really unexpected reaction of the cloth. Let's just add the collision effect onto these other objects, or these boxes right here, or these 3D objects right here, and now hit play. Oh my gosh, to see how the cloth will react on to these. Now let me just go ahead and outer, inner. Let me just go and I want to find the collision area, or the collision boundary, and I have literally no idea. I've never here cloth collision. There is quality of collision and distance, and yep, that is pretty much it. Yes, that is what I exactly wanted. Quality of collision can be raised to 5. Yes, that is something that I wanted to have. Quality can be 4, distance can be before that Okay, I'm also gonna add some friction. Friction is 5 here and friction is 5 here as well. So let's just add more friction here. And how about we create it, make it large. Oh my gosh, that looks so good. That looks absolutely fun to watch. Let's just play that back again and watch it from a distance. That looks so cool. Oh my gosh. It kind of glides really well. Oh, it passes through. Okay, that was because it sticks too much. When something sticks too much, what happens is it kind of start to pass through that object. Yeah, that is real motion. It looks so cool now, seriously. Oh my gosh. That was cool. Now this video tutorial is done. We are done with explaining and understanding how different stages are done in Blender, or how to work on different subjects, or how Blender deals with different subjects. Now we're going to move to the next lesson. In the next lesson we are going to talk about customizing Blender for personal or professional use. So see you in the next lesson.